In section 2.3, other set operations and their properties, students will be able to understand and explain the following: relations between set operations and logic connectives, Venn diagrams to sort and reason with data. Consider the following sets. C is equal to X such that X is a college graduate. S equals X such that X earns at least $40,000. Suppose we want to mail a questionnaire to all individuals in a certain city who are college graduates and who earn at least $40,000. Then the individuals to receive the questionnaire include those common to both sets C and S. The intersection of the sets C and S is the shaded region. So in this intersection we have both those that are college graduates and those who earn at least $40,000. So the definition of intersection is as follows. Suppose we have sets A and B written with a symbol that looks like an upside down U. This is A intersection B is the set of all elements common to both A and B. So here's our formal definition. The intersection of A and B is the set X such that X is an element of A and an element of B. This "and" is very important. The keyword is "and," which implies both conditions must be met. In example 14, let's consider the intersection of A and B in each of the following sets. We have A equals 1, 2, 3, 4, B equals 3, 4, 5, 6. Now remember, the intersection is what's in both. They both contain a 3. They both contain a 4. So the intersection must be just 3 and 4. So we have the intersection of A and B equals 3 and 4. For part B, set A is 0, 2, 4, 6, even numbers including 0. And set B is 1, 3, 5, 7, so all of the odd natural numbers. Now think about it. What does the evens have in common with the odds? Well, they don't have anything in common. So the intersection between A and B is empty. If the intersection between two sets is empty, we call them disjoint. So two sets that have nothing in common are known as disjoint sets. For part C, we have A equals 2, 4, 6, 8, and B equal 1, 2, 3, 4. So what do these two sets have in common? Well, they both have a 2, they both have a 4, they both have a 6, because this set's just counting 1, 2, 3, 4, 5, 6, 7, 8. So this is all of the natural numbers. This set is just the evens. So the intersection between these two sets is just the even numbers, or A, because A is the set of even numbers. In our previous example, if C represents the individuals with a college degree and S represents the individuals earning at least $40,000, we can use a Venn diagram to display the information. Let's suppose we add additional information. If we know that 4,800 individuals have college degrees, 5,400 earn at least $40,000, and 1,200 have a college degree and make at least $40,000, then we can do the following calculations. 4,800 minus 1,200 is equal to 3,600 have college degrees but earn less than $40,000. 5,400 minus 1,200 equals 4,200 earn at least $40,000 and do not have a college degree. Now, these calculations might seem difficult to understand, so that's why we need a Venn diagram. We can put all the information in a Venn diagram. In this example, we can clearly see now that 1,200 have both a college degree and make at least $40,000. These individuals in the middle have both a college degree and make at least $40,000. On the right side here, we have individuals that make over $40,000 but don't have a college degree. On the left side, we have individuals that make less than $40,000 and have a college degree. Now we can see our information, and it's nicely displayed as a Venn diagram. Suppose we want to mail a questionnaire to all individuals in a certain city who are college graduates or earn at least $40,000 or both. When we use the word or in math, it could mean both. Then the individuals to receive the questionnaire include those who are members of set C or set S. Again, this or is inclusive. So the union of set C and S is the shaded region. So you can have a college degree or earn above $40,000 or both. So the union is the entire two circles shaded in together. The union of a set A and B will be written with this symbol. It looks like a letter U here. A union B is the set of all elements in A or in B. Now remember, this or could also include both. So our formal definition is A union B equals the set X, such that X is an element of A or X is an element of B. The keyword is or, which implies one or the other or both. So just remember, it can include both or one or the other. Let's consider this example. We have A union B. So for the set A union B, you could have 1, 2, 3, 4, and you could have 3, 4, 5, 6. So all we have to do is list all of the elements, but don't have any repeats. So A union B equals 1, 2, 3, 4, 5, 6. Let's consider set A being equal to 0, 2, 4, 6, so the even numbers, and B being equal to 1, 3, 5, 7. Well, for the union, you could have a 0, 2, 4, 6, and you could have a 1, 3, 5, 7. So we're just going to list all of the elements again, starting from 0. So we have the union is 0, 1, 2, 3, 4. Again, we're going to list all of the elements, 1, 2, 3, 4, 2, 4, 6, 8, so all of them without any repeats. A union B equals B since every element of A is in B. Let's get started with Venn diagrams. Let's find the correct shaded region. For the first example, I want to shade region A. Region A would be this entire circle, just the circle with A in it. So that one's pretty easy. For the second example, I want to find B complement. B complement is everything except B. So I'm going to shade the entire universe except B. Everything except the circle for B. And this is our shaded region. For the third example, we're looking for the intersection of A and B. The intersection is the same as the overlaps. What is common in both? I have the center here is in both A and B, so we're going to shade the center. For the fourth example, I'm looking for A union B. A union B is everything in A, everything in B, or what's in both. So we include the overlap in this case, so we have to shade both of the circles completely, including the overlaps, for A union B. For the fifth example, this one's a little bit more difficult, so I like to label some regions. The outside of the circles, we'll call that region 1. This part of circle A is region 2. The overlap is region 3. And this part of circle B is region 4. Now, these numbers that I use are random. I could have done it 4, 3, 2, 1, and I would still get the correct shaded region. Now, let's look for A complement. A complement is everything that's outside of A. Well, everything outside of A would be region 1 and region 4. I'm going to intersect that with B. B contains region 3 and region 4. Now, what's the intersection between 1, 4 and 3, 4? That's going to be the overlaps. What do they have in common? They have a 4. So I'm just going to shade region 4. This is our solution. We're just going to shade everything in B except the overlap with A. For the sixth example, we'll do it the same way. Let's say that's 1, 2, 3, 4. And we're going to look for region A. Region A is 2 and 3. Union that with B complement. B complement's the opposite of B. Everything outside of B would be 1 and 2. Now, the union of these two is what is in one or the other or both. I'm going to shade everything from each of these. So we're going to shade region 2. We're going to shade region 3. We're going to shade region 1. Remember, it's one or the other or both. And so this is our shaded region. It's everything except 4. So this is it. For this example, we'll do the same process. Let's label 1, 2, 3, 4 for the regions. And now we have to be extra careful. I'm looking for A intersect B complement. A intersect B complement. Let's look for region A first. That's going to be 2, 3. Intersect that with B. That's region B is 3 and 4. But wait, we have to take the complement also, so we have a bar on top. What's the intersection between 2, 3, and 3, 4? The intersection is just 3. So I have the complement of region 3. What's everything except region 3? Well, that's going to be equivalent to 1, 2, 4. So let's shade everything except region 3. Everything except region 3. For this example, we want to look for A union B complement. A union B complement. I could do the same process by labeling it with numbers, or I could look at A union B. Let's look for A union B. We know A union B is the entire circle for A, the entire circle for B. We know that already from example 2. So what's the opposite of the entire circles of A and B? It's all of the outsides. So for this one, I could just use my reasoning to deduce is just the outsides of circles A and B. So there's more than one way to do it. Since we already done A union B, we know the opposite of A union B. Let's look at page 2. Let's look at page 2 of our Venn diagrams now. In page 2 of our Venn diagrams, we have 3 sets, A, B, C. So let's look at that. The first part is to shade in region A. That's the same as earlier. We're just going to shade the entire circle for A. And for the second example here, we're going to look for A union B. Well, that's everything in A, or everything in B, or both. So nothing new so far. The intersection of A and C would be what's strictly in both, so I'm going to shade only the overlaps. In the fourth example, I want to find the intersection of A and B, but intersect that with C as well. This one's a little bit more difficult, but if you think about it carefully, I want to find the intersection between all three. The intersection between all three is this tiny little spot where they have just this tiny region in common. That's the intersection of all three. A complement. A complement is everything outside of A. So we're going to shade everything that is not A. Everything that's not A. For this example, I'm looking for A union B union with C. All of A or all of B or all of C. So we're shading everything in A, everything in B, everything in C, including any overlaps. Now we're going to get to the good stuff. A union B complement. We already done this in the previous worksheet, but we'll do it again. I can look at A union B first. A union B would be this region here. A union B would be circle A, circle B, and the overlaps. So A union B would be this circle and this circle together, but we want to take the complement of that. So the complement of A union B is the opposite of A union B. So everything outside of A, everything outside of B. That is our region. A intersect B complement is the opposite of A intersect B. A intersect B is this region here, but we want to do the opposite of that. Everything that is not in the intersection of A and B. So I'm going to shade everything except that overlap. So everything except that tiny little overlap in the middle. It's getting more challenging, but we can do it. For A complement intersect B complement, let's just go back to our technique with the regions. I'm going to label the outsides of all the circles as region 1, this as 2, 3, 4, 5, 6, 7, 8. Again, my numbers are random. You could do it in any order you want and still get the same answer. So let's look for A complement. A complement would be everything outside of A. That would be 1, 4, 7, 8. all of the numbers that are outside of A are 1, 4, 7, and 8. I'm going to intersect that with B complement. B complement would be everything outside of B. That would be 1, 2, 5, and 8. Now the intersection between the two would be any overlaps. What do they have in common? They have 1 and 8. That's the only thing they have in common. So that is our intersection between A complement and B complement. So we're going to shade region 1 and we're going to shade region 8. Region 1 is everything on the outside. Region 8 is this part of C. So it's getting more difficult. I would use the labeling method for the regions if it gets more complicated like this example. Let's label it again as 1, 2, 3, 4, 5, 6, 7, 8. Let's find A union B union C complement. A union B union C would be everything in A, everything in B, and everything in C. So I would have the numbers 2, 3, 4, 5, 6, 7, 8. But we have to take the complement of that. So what is in our universe that's not in this list? Well, that's the number 1. So we're just going to shade region 1, which is everything outside of our circles. Everything outside our circle is going to be shaded. In this example, I'm looking for A intersect B intersect C complement. Now I know the intersection between all three is going to be this tiny place right here in the middle. That's the intersection between all three, which we already done earlier. Now to find the opposite of that, well, we shade everything that's not in the intersection. So it's this entire region here. So this one I didn't need to label the regions. It was pretty easy to do. So everything except that tiny little triangle in the middle. For this example, let's label the regions 1, 2, 3, 4, 5, 6, 7, 8. Now we're looking for A complement. A complement would be everything outside of A, which is 1, 4, 7, 8. 1, 4, 7, 8 is outside of A. Intersect that with B complement. B complement is everything outside of B. That's going to be 1, 2, 5, 8. I'm going to intersect that now with everything outside of C, which is 1, 2, 3, 4. And now we're going to find the overlaps. What's common in all three of these? They only share a 1. So we're going to shade region 1. For these examples, let's start with labeling the regions again. 1, 2, 3, 4, 5, 6, 7, 8. And I want to find A intersect B. A intersect B. A intersect B would be any overlaps between A and B, so that's the numbers 3 and 6. We'll union that with B intersect C. B intersect C would be the overlaps of B and C, so that's 6 and 7. Alright, so now we need to find the union. Remember, the union is what's in one or the other or both. So I need to shade entire region of 3, 6, and 7. So that's 3, 6, and 7. For this example, let's label it again. 1, 2, 3, 4, 5, 6, 7, 8. I want to find A union B. A union B would be everything in A. So that's 2, 3, and everything in B. So we have 2, 3, 4, 5, 6, 7. Remember, A union B is everything in A, 2, 3, 6, 5, and everything in B, 3, 4, 6, 7. So we have all the numbers from A and B combined. Now I'm going to intersect that with region C, which is 5, 6, 7, 8. So what's the intersection between these two? They both share 5, 6, 7. They both share 5, 6, 7. So I'm going to shade the region in the middle with 5, 6, and 7. For this example, do the same thing. Label the regions. And if you have time, pause the video. Try the questions on your own. A union B intersect C. So I got to do the B intersect C part first, and then we'll union that with A. So for region A, we have 2, 3, 5, 6. I'm going to union that with B intersect C. B intersect C would be 6 and 7. That's the overlaps of B and C. And now we'll find the union. Remember, the union is in both or one or the other. So we have 2, 3, 5, 6, 7. For the union, you just have to list them all. So we're going to shade 2, shade 3, 5, 6, and a little bit of 7 here. So all of A and a little bit of this overlap. And for the very last one, we'll have to do A complement intersect with C. Then intersect that with B. B is equivalent to 3, 4, 6, 7. I'm going to intersect that with A complement intersect C. A complement is everything outside of A, and intersect that with C. So we're going to have, that's just 7 and 8. Well, think about it. If you don't understand, everything outside of A and in C. So everything outside of A that's in C would be just 7 and 8. Now I'm going to find an intersection between these two, and that looks like they just have 7 in common. So we're going to shade region 7.